right, this is concept development for Module 6, Lesson 11. Look up here at the first chart. It says line L, rule triple X. So what does it mean when it says the rule is triple X? What operation are you going to do? Well, triple X means multiply by 3, right? So before you complete your chart and draw a line L though, what do you predict the line L will look like? So number one, it's a multiplication rule. So it will pass through the origin. The y coordinates are 3 times the x coordinates. So the line will be pretty steep. So I want you to complete the chart, plot the points, and draw the line. 2 more things. Label the x and y axis. So label your axes and label the origin. Come back and check your work. All right. Did you get 0, 0, 1, 3, 2, 6, 4, 12? Did you plot your points? Did you label your axes? Label the origin, plot your points, and draw your line. One other thing we didn't talk about is making sure, understanding what intervals your coordinate plane is counting by. So here, 1, 2, 3, 4, 5, 6, 7, 8 is just going by ones on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8. It's going by ones on the x-axis. So say the rule for line M. Triple x and then add 3. So how is the rule for line M different from the other rules we've used to describe lines? We've only had rules that showed lines for adding something to x or multiplying by x by a number. This rule has 2 operations. So show me the coordinate pair for the point whose x coordinate is 2. So x coordinate is 2. What is the y coordinate going to be if you have to triple x and then add 3? So triple x means 2 times 3 is 6, then add 3. 6 plus 3 is 9. So your coordinate pair would be 2, 9. All right, fill in the rest of the missing y coordinates in the chart for line L. Plot each point from the chart, then use your straight edge to draw line M. Come on back when you're done. All right, did you end up with 0, 3, 1, 6, 2, 9, 3, 12? Did you plot your points and draw your line and label it? All right, what do you notice about lines L and M? What do you notice about lines L and M? Well, they are parallel lines. Line M doesn't go through the origin. It's a multiplication rule that doesn't go through the origin. So the lines are equally steep, but line M is just farther from the x-axis. The lines are identical, except line M doesn't pass through the origin. It passes through the y-axis at 0, 3. So, do lines L and M intersect? No, because they're parallel. Which line is steeper? Well, they're actually equally steep. What is the difference about the lines, though? The points on line M are farther from the x-axis than the point on line L. So line M does not pass through the origin. It goes up by 3, right? All right. Now, Let's look at another mixed operation rule. Triple x and then subtract 2. So before we added 3, now we're going to subtract 2. Show me the coordinate pair for the rule when x is 1. So what will y be if x is 1 and you have to triple x and then subtract 2? Write it down. So you're going to end up triple x and then subtract 2. All right, so when you triple x, multiply it by 3 and then subtract 2, you end up back at 1. Correct? All right, based on the patterns we've seen, what do you predict line N will look like? So if we jumped above our just triple x for then add 3, so we're keeping the triple x, but we're subtracting 2. Where do you think our line is going to go or shoot through for line N? Well, it won't go through the origin because when x is 0, we won't get 0, 2. I mean, we get 0, 2, but I don't know what to do with that. It's going to be parallel again, but this time it will fall below line L because we're subtracting this time. So what I want you to do is solve for the rest of your chart. Solve for your y coordinates, get your coordinate points, coordinate pair. Then I want you to plot it and use your straight edge to connect the lines. Did you end up with 1, 1, 2, 4, 3, 7, and 4, 10? Did you plot your points and label it N? So looking at the 3 lines, what have lines L, M, and N taught you about lines generated from mixed operations? What have you learned by looking at operations with looking at the lines generated from mixed operations? Well, you can generate parallel lines involving multiplication, but you have to add or subtract after multiplying. Not every rule with multiplication will produce a line that passes through the origin. If the multiplication part of the rule is the same for both lines, adding after multiplying makes the points in the line shift up by whatever you're adding. Subtracting after multiplication makes the points on the line shift down if the multiplication part of the rule is the same. Isn't that correct? All right. We are moving on to, nope, we're going to stay right here and we're going to use the same chart, but this time we're going to create a new chart and we're going to multiply by a half. Then you are going to add 3/4. So first, think about this for a second. So here's our x and our y. If x, we're going to multiply x by a half. Multiply x by a half, and then you're going to add 3/4. So what do you predict this line could look like? So we'd have to add 3/4 after multiplying by a half. So that means the points on this line would shift up 3/4 more than the points on the line that you see when you're just multiplying by half. The rule has you multiply by 1/2 first. Multiplying that by a half will be a line that is less steep than multiplying by a whole number. Remember, what do we know? When you multiply it by a number greater than 1, your answer, your product will always be greater. If you multiply by a number less than 1, your product will always be less, right? All right, so it's a mixed operation, so it won't go through the origin. So how will you find the y-coordinate for this point if x is 1? Try that out on your own. All right, so you should have 1 times half plus 3/4. So what's 1 times a half? It's 1/2 plus 3/4. And a half would really be 2/4, correct? Plus 3/4, which would give you 5/4. 5/4, which would reduce to 1 1/4, correct? Yes. So, show me the coordinate pair for this rule when x is 1. So it would be 1 either 5/4 or 1 1/4. So, what is the first step in finding the y-coordinate when x is 1.5? So what if the x-coordinate is 1.5? Well, you still have to multiply by half, and then you add 3/4, right? Now, if our x-coordinate is then 1.5, what will our y-coordinate be? Well, it would still be, you'd still have to go 1.5 times a half plus 3/4. But can you multiply a mixed number like this? No, you have to change it to an improper fraction. So it'd be 2, 3 halves times 1/2 plus 3/4. So 3/4 plus 3/4 is 6/4. And that would end up being 1.5. All right. Now, I want you to work independently and show me the coordinate pair for this rule when x is 3/4. So now let's add x is 3/4. You can just work down here. What do you get? What is your y-coordinate when x is 3/4? All right, so I went 3/4 times 1/2 plus 3/4. So 3/4 times 1/2 is 3/8 plus 3/4. Well, I can't add those because they don't have common denominators. So I have to change it. So it's 3/8 plus 6/8, which ends up being 9/8, which ends up being, reduces down to 1 1/8. So it's 3/4 is your x coordinate, and 1 1/8 is your y coordinate. Now, would the line for this rule contain the point 3 2/4? So now try 3 for the x. Would you end up with 2 1/4? Try it out. See if there's a way for you to end up. Can you use multiply x by 1/2 and then add 3/4? Is there any way to end up with 3 2 1/4? So how would you end up with 3? If you're multiplying by a half to start off with, what would you have to have in order to end up with 3? Well, 3 times 1/2 is 3 halves. And 3 halves plus 3/4 would be equal to 9/4. 9/4 is the same as 2 1/4. So yes, if I take the x coordinate and multiply it by 1/2 and then add 3/4 to the product, I get 2 1/4. So 9/4 plus 3/4 equals 12/4, which equals 3. Wait, I found a mistake. We're supposed to end up with 2 1/4. So 3 times 2 is 6. 6/4 plus 3/4 equals 9/4, which is equal to 2 1/4. All right. So what about 2 1/2? If x is 2 1/2, is there any way to get 2 1/4? Try it. See if you can try 3 1/2 as your x coordinate. Use this operation and see if you can end up with 2 1/4. Try it now and see if you can get that. Okay, so I actually worked backwards. I subtracted 3/4 from 2 1/2 and got 1 1/2. And then I doubled it, but I got 3. But the coordinate pair we were given had an x coordinate of 3 1/2. So I knew that this pair wouldn't be on the line. All right, we are finished with concept development for Module 6, Lesson 11. Here is our big idea for today: being able to analyze number patterns created from mixed operations. All right, good luck. You have now, it is your job to go through the problem set. Complete the tables for the given rules. Draw the line on the coordinate plane. Compare and contrast the lines using parallel, perpendicular, using lines that we've discussed before in order to compare them. Using the idea that if you multiply by a number greater than 1, your result's going to be greater. Subtracting, adding. Based on the patterns you see, predict the line for the rule double x and then subtract 1. Write it here. Draw the line on the plane above. Circle the points that the line for the rule multiplied by x, multiply x by 1/3, and then add 1 would contain. So you actually need to go through and solve those problems, explain how you know, give 2 other points that would fall on this line. Number 3, again, you're going to complete the tables for the given rules, draw the line in the coordinate plane, compare and contrast the lines. Based on the patterns you see, predict what the line for the rule half x and then subtract 1 would look like. Again, apply this rule to these 4 coordinate pairs and see if they would lie on that line, and then give 2 other points that would fall on the line that the ones that you choose. Here's your exit ticket, and here's your homework. All right, I will post the debrief of Module 6, Lesson 11, so you can come back and check to see how you did on the problem set.